to Mastering the Ball Corner, brought to you by learningalias.co.uk. I'm Graham Bullock, and I'm going to be telling you how to make Ball Corner to Class A standards and how to sort out any problems that you may come across on the way. This is part 2. We need to put tangency locators on the 4 surface boundaries so that we can keep an eye on what's happening to all of the boundaries whilst we are manipulating CVs on any one given boundary. Now, sometimes when you have a problem and you're freehand modeling, you can't always use the align tool, and you can't always use the system. When I say the system, I mean you can't use the square tool itself to control the surface you're building. You do have to model it by hand or directly. So let's just move a CV. We're going to have to change our step size to 0.001. And if I just move a CV, I want to show you something. There you are. So I moved it out of tangency and I move it back into tangency, and the other way out of tangency. Okay, so assuming that that CV was not correct, and neither was that one, how would we fix it? Okay, well, we look along the view here and try to find something that doesn't look right. Now, if you look here, you have these 2 CVs here. I need to go in closer, and that one's too low. And then if we look here, I'm going to turn off the locators for a moment. If we look here, we can see there's something wrong with that CV. So let's put some locators on again. You always have to look at all 4 boundaries. It's no good looking at just one, because you fix one and another one goes out of sync. So come down here and move CV. Project. Don't put parallel on, just move CV and project. And then we'll pick that CV again, and now pick this hull on the adjacent surface, and this is going to act as a vector. And if you notice what happened, as I hit that CV jumped up into tangential relationship with this surface. And then if I pick that CV there and I pick that hull, the same thing happens. So by using that tool, you can also use it in a slightly different way by picking parallel, and then you pick the CV, and then you can pick any of these hulls, and you can slide that CV along in line with that vector. I'm going to leave you with that then, how to build a 5511 ball corner single span to Catia V5. And if you don't believe me, let's go and have a look. Construction options. I'm using user defined 20, and then if we go down the bottom here, we can have a look at the tolerances, continuity, and there we are. 0.001 is our maximum gap, and our continuity angle is 0.1, and continuity curvature is 0.1. So that's Catia V5 tolerances. I can show you it. Catia V5. Come down here, and there you are, you see. 0001.1.1. So that's what we were working to. The only reason that I didn't have it set to that was so that I could use a bigger font for demonstration purposes. Well, there you are. I hope that you found that helpful, and if you enjoyed it, I invite you along to my website learningalias.co.uk to find out more. Thank you.